Let's discuss what is Mfsk, that is frequency shift keying. We have already seen what is binary FSK. In binary FSK, 0 is sent through frequency of F1, cosine of F1, and 1 is sent through cosine of F2. And in M-array FSK scheme, similarly there are M various possible signals, and the form of the any FSK signal would be this: cos of 2 pi Fc plus I delta F into t. There might be some amplitude, which I am ignoring for time being. There might be some amplitude. So I would vary from 0 to m minus 1, and time duration over which this FSK signal will be available, or the communication time will be n times TB, where n is log 2m, because each of the signal carries n number of bits, where log 2m or log 2m number of bits. So first signal would look like cos 2 pi fct, put I is equal to 0. So you can write as 0t, s1t, cos 2 pi fc plus delta f, 2 delta f, and so on, where delta is the separation between two consecutive frequencies. So now our aim is to choose all of these frequencies or the frequency separation in such a way that all of the signals are orthogonal. So for this we have to ensure that this integration, that if we choose any jth frequency signal and the kth frequency signal, then they must be orthogonal to each other. Just choose any two, this one or the any jth and kth. This is j and this is k. So I'm talking about frequency, right? Any two signal and they will be orthogonal. So just we have to solve this integral. We know cos c cos t, so we apply formula of cos c into cos t, that is half cos c plus t by 2 plus cos d minus c by 2, and therefore we get this. And once we integrate this, it's very simple to integrate this. Now in order to ensure that these terms are 0, we have to ensure that 2 pi k minus j delta f ts 0, the lower will always be 0, the cap should be some integer multiple of pi, n pi if you remember. So I am just calling it integer multiple of pi. So for this, if you just replace, this will give you delta f as some integer multiple of pi k minus j ts into 2 pi. Pi goes away. So we want minimum value of what should be that minimum. This is the any delta f which will satisfy this, right? If you choose this delta f, it will satisfy that any kth and jth will be orthogonal. So the minimum should be 1 upon 2 ts. We take this value as 1, so it will be 1 upon 2 ts, and you can write it as ts is ntb log 2 ntb. So the minimum separation which is required for sk, all the signals to be orthogonal, is 1 upon 2 log 2m into t. So how would you draw the constellation? Constellation is, first you have to find out all the you have to provide all the possible signals, and it gives the Gram-Schmidt procedure gives the orthonormal basis, right? Orthonormal basis. Since S1, S2, S3, S4 which we have chosen is already orthogonal, so the phi 1, phi 2, phi 3, phi 4 can be easily derived, and just you have to normalize because they are orthogonal as well as normal. So just you have to divide it with the energy of each signal. Maybe the energy is Es. So this is S2, this is S3, this is S4. or if you want, since we have chosen 0, you can write 0, 1, 2, 3, and this will be 5 1t will be S0t divided by root ES. Phi 2 will be S1t, because I have just changed it to 0 1 2 3, since if you remember here we have started with 0 1 2 3, that is why. So once we get the orthonormal basis, so since S0t is phi 1t, phi 1t is S0t root ES, therefore S0t will be phi 1t times root ES. So in S0t, only component of phi 1t is available, phi 2t, phi 3t, phi 4t is not available. Similarly, for S1t, S2t and S33, the component of phi 2, only corresponding phi 2 or phi 1 is available. So you can just draw it in the constellation like this. That this is your S0, this is your S1, S2 and S3. The next question is, once we get the constellation, what is the bandwidth occupied? So bandwidth occupied by any Mfsk signal is M delta F, where delta F we have derived as 2n TB. So it is 2n TB. One important point here is, if we increase M, since for example M is 8 and here M is log 2m, so this numerator increases linearly, whereas denominator increases logarithmically. So if we increase M, the bandwidth required for Mfsk decrease. You can check it. M and bandwidth, take M as 8, the bandwidth is 4 by 3 TB. When M is 16, it is 16 by 8 TB, which is 2 TB. So of course 2 by TB is greater than this. So if M increases, bandwidth of Mfsk increases. On the current contrary, if M increases, bandwidth of Psk and Com decreases.